there. Thank you so much for joining us today for this webinar. My name is Joy. I am part of the team here at NextGen. And before I pass things over to Mike for the technical piece of this webinar on ProModel, just want to quickly just let you know kind of who we are at NextGen. NextGen is an Autodesk partner in the design and manufacturing space. We have been around since 2008. And originally started off with an emphasis on CAM, but as we have grown as a company and with our customers, we've expanded to really offer solutions in the entire design and manufacturing space. And so that is why ProModel, we're so excited to work with them and partner with them and rep this as a new product for us. So in addition to that, just kind of a high level, just to brag about ourselves quickly, because of that, deep CAM knowledge, we have been the #1 CAM partner for Autodesk 6 of the last 7 years. And earlier this year, we were named the Autodesk Top Service Partner. And that was very exciting for us. And we just plan to hold on to that title going forward. We also are a gold partner with Autodesk as well as an authorized training center. And so we have lots of training and webinars that we do on a monthly basis. And you can find all that on our website, nextgencam.com or nextgensolutions.com. So just a little shameless plug, next week we are having another webinar on Upchain. So if you were looking for a data management or product management or product lifecycle management solution, that is definitely worth checking out. So with that, I'm going to pass it back over to Mike and take it away.
Hello, everybody. Thanks for attending. My name is Mike Joliker. I'm the director of the Autodesk business unit at ProModel. I was employed actually by Autodesk for about 22 years before coming to ProModel. I got a look at this amazing technology as I worked through it, and I thought, you know what, I really want to get on board with these guys. So with that in mind, I'll run you through. We'll give you some demonstrations of the software, and we'll talk a little bit about the workflow and the process and the company as well. So discrete event simulation, or the ability to mathematically simulate a process over time, has been around, well, since the beginning of manufacturing, really. So ProModel has been in business of discrete event simulation since 1989. So the software is designed and written by experienced lean practitioners and process modelers as well. So we're a critical path workflow for decision-making in Fortune 100 accounts and job shops alike. So there's thousands of customers out there that are working globally, utilizing our technology today. What is new is that we realize that over 90% or 95% of these studies in manufacturing either originate from or involve a spatial layout that came from AutoCAD. So with that in mind, we designed a better mousetrap. So we partnered with Autodesk, and we came up with an application that runs right inside of AutoCAD that will allow us to be able to enjoy the benefits of discrete event simulation inside of AutoCAD, allowing a wider audience within companies to be able to use this technology to help companies save money. So if we were to look at it, Autodesk tools provide a great foundation for building an integrated factory model. If there are familiar tools that you're probably already using today. ProModel will provide the ability to turn your CAD layout documentation into a powerful enterprise decision-making tool by providing throughput simulation. And this helps customers get the best return on investment for their process changes, and in turn, reduce cost of manufacturing of their products. So most business intelligence systems are good at hindsight. So they look at what happened and why did it happen. And this is important when you're debugging an existing process, but it's wasteful in terms of the lost time and capital that goes on. In other words, you have to break it and then you have to fix it. And all of this occurs after investing a lot of money to get a line or a process running in the first place. And what's interesting, that's kind of what lean methodology follows, right? In Six Sigma. So we put the line in and we tweak it, but we can find all of this stuff early on. So this allows us to not experience the pain twice. It allows us to be able to figure out these things inside of the software before we commit to buying tools. So it allows us to be able to predict what's going to happen. And also when we find issues or problems with that, how can we make that better, or how can we solve those problems as we work? So tools like Excel can provide us deterministic data, but it can't provide what's really needed, which is the performance of a system with process variation over time. And because of this, the data provided from something like Excel is not really showing the picture as it is, or more importantly, what it could be. So the ability to predict the future, prescribe solutions that impact the future is where ProModel shines. And all of this happens before committing capital to implement, resulting in lower cost of goods and risk mitigation for new processes for existing process change. So the methodology that we follow is we help you visualize the process, be it a totally new process design or an existing design requiring improvement or modification. After visualizing, we can analyze the results using configurable environments. So once we have all of that, we can experiment with the results by running scenarios, utilizing different scenarios like manpower studies, equipment utilization, and cost analysis, for example. So as we know, manufacturing processes are complex. As mentioned earlier, tools like Excel can provide deterministic data, but can't really provide what's really needed, and that's the performance of a system with process variation over time. Again, what you're getting from Excel is data, but it's not really accurate data because it doesn't take into consideration variability, nor does it take into consideration time. So there's a lot of factors to consider. The reality is what you think is the case a lot of times based on past experience, maybe isn't. So better, more reliable data provided by an easy to understand and very configurable environment not only allows you to test current ideas, but future ideas, taking all variables of the manufacturing process into consideration to give an accurate result that can be measured over time. So until now, the tools that were out there, the way that people went about this is they would go out and talk to the industrial engineer, the decision maker, would have an idea for a layout. And a lot of times it was based on either something they already did, or it's the change of a new process or a change of a process, perhaps even adding a new process or a new product to a line. So what they would do is they'd reach out to their layout engineers and process engineers, and they would say, hey, can you give me the layout drawing of that area that I'm working on? So what they would do is they would toss it over the wall to them, and it would be a DWG file. So whatever tool they happen to be using would require them to first convert this to something like a TIFF file. Then they would have to scale it. And then once you got that, then you could start building your process on top of it. Well, that isn't really too bad, you know, when you're first doing your layout and first thinking things through. But as we all know, engineering processes usually are 20% of the new initial idea, and then 80% massaging that process or that idea. So what ends up happening here is a broken workflow. That means that every time the industrial engineer makes, does something or makes a change, he's going to have to tell the process engineer, who's going to have to change a drawing, who's going to have to bring it back in. And this workflow goes over and over again. It's very disjointed, and it's time consuming, and it's error prone. So unfortunately, in the past, that's how ProModel was until now with the ProModel AutoCAD edition. So with the new edition now, it allows companies to be able to democratize this simulation capability. It allows more participants to simulate easily using the AutoCAD edition and allow dedicated industrial engineering staff to further simulate the process using Simulation Suite or some of the more advanced tools that tool can bring to bear. So how do these tools work together to save money and reduce risk? So the first thing we look at is the factory design utilities. These excel in helping customers avoid excessive costs and risk in change order. That is, making sure that everything will physically fit into the space that's allotted and that the equipment interfaces physically as well. So the idea is we can avoid change orders on installation, which can drive up your project cost substantially. What it doesn't do is allow planners to see how this plan change will affect the cost of the products being manufactured, the ability to confirm that the design will meet the required throughput to today's demand and the future demand. And that's where ProModel comes in. So what we do is we allow those that plan change, be it for new products, process improvement, or automation, or being acquired bringing acquired companies into the corporate fold, allows them to fully understand the process that is being designed and that it'll meet the production needs and be cost effective, either lowering the cost of manufacturing or allowing more manufacturing agility. So the combination of these tool sets allow customers to build out a facilities digital twin that can be used over and over again to test ideas before committing capital. So it's very easy to make a new project fit the right way the first time. So what we worked with, and when I was working with Autodesk, we came up with workflows where we would first go and laser scan the area and be able to get its current state. And then we'd utilize recap to make sure that we could properly place the equipment in context to the actual building and area state. So we can then use the model to communicate the design intent and building context. So the creation of things like demolition docs, installation docs, and visualization of new equipment can be put into place and easily created. We can also simulate how this new or reworked process is going to perform. So we get more accurate layouts, meaning less change orders and installation, and accurate production data, meaning more profits for your company. And this is a quote from a customer that we had worked with in the past. Just by using the 3D workflow alone over 2D, they found that they were able to reduce their costs of installation substantially. And they were able to bring in their product or their project not only on time, but actually before time. So it was a very good workflow for them. At that time, though, we didn't really have anything that did the other work, which would have been the manufacturing throughput. So this is what we're going to be talking about today, the ability to be able to understand this. And this is a quote again from another customer that we worked with that was looking at doing a rather expensive line change. They weren't able to get the throughput that they were hoping for, and were looking at buying a new piece of equipment that was very expensive. So we came in and worked with them, showed them how to use the software. And after modeling their process, they found that they didn't need to purchase this other piece of equipment. So in other words, they were looking at what they were not going to do. And this ended up saving them $1 million because they were not going to order a machine, in this case, a 5-axis Mazak, that they were going to order. So this is the workflow that we would use at a high level. So basically, we can either create an asset or AutoCAD layout using the assets that we have, using the factory design utility, or we can use just a plain AutoCAD drawing that has blocks in it to represent what the locations are. So we can pull that in. There's a ribbon in the top of the AutoCAD environment that has all of the ProModel tools in it. So again, very easy to learn and easy to work with. Once we have this, we simply can simulate and watch the model run and see the animation as it runs inside of AutoCAD. And from there, we can start seeing the output metrics of everything that's there. So we can see how everything performs and work our way through it. And we can go even further than that, where we can have what if scenarios. So we can contrast different ideas against each other to make sure that we're picking the best idea that basically will work around the KPIs that we are using to determine success. So from that, we can go back in, and as we know, we're going to be seeing things in these results that may affect us to have to make changes to the layout. So like in this case, maybe we're adding another piece of equipment. So we can go add that in there, and as we move things, everything updates as it goes. So it all stays in the same environment. Again, eliminating chances for change. And then from there, if we want to see this in 3D, we can open it in Inventor and be able to view the layout and model in 3D. So from there, let's go ahead and do a little bit of demonstration to show how this works. So what we're going to show you is how easy it is to streamline your layout and ensure design confidence in the manufacturing process design. So we have a representation of our layout, our proposed area in AutoCAD. So these are just AutoCAD blocks, as I had mentioned earlier. These represent the new pieces or the machines that we are going to be putting into place here. So we have 2 CNC machines and 2 washers that are going there. So the ProModel environment is a ribbon all of its own inside of AutoCAD, and also has a browser that allows us to be able to work through our layout. So working left to right and top to bottom makes it easy to go through. So in this case, what we're doing is telling these are the locations where we're going to be processing our part. And it could be anything. It could be machining. It could be making hamburgers. Doesn't make any difference. But we can grab that information. So now that we have those locations and we have things running through, the next thing we need to do is tell it what part we're going to run. So we can run multiple parts through here at once, as many as we want to. But for the sake of simplicity, we'll run it with just one part. We can apply initial costing to that part as well, and we can give it a basic size. So say, for example, we don't know what that part is yet, but we kind of know about how big it is. And this will become important a little bit later when we start looking at things like conveyors, because the tool is smart enough to understand how things need to be oriented and how many we can fit on a conveyor. As we know, a conveyor can work like a buffer. So now that we've got all of that information in place, we can go in and take a look here, and we can start adding our flow. So from here, we'll just add in the flow as we need it. And I'm going to choose how I want this to go through my machines. So I can choose all parts if I wanted to, or in this case, I'll be specific. We're going to grab the casting and put that in here. So we'll simply pick the direction or the order that we want things to go through. Now, this can be reordered later on if you wanted to, but in this case, we just picked them as they went. So we can see now this is the flow order of things as they go through. And now what's done is we have a default value that's applied to each of these processes that you can go ahead and change. So in this case, we can take a look and see what the industrial engineer said that he figures we're going to need. So he's looking at machines, he's looking at a Chiron, and he's also looking at parts washers. He's given us time in here, and you'll notice now we can use a distribution builder to be able to choose how we want to represent the time spent on each of these processes. So in this case, we're going to go with a normal distribution. We're going to say 2.5 minutes is the average, and the deviation is about a half minute. Okay, so that'll be important, especially when we start running this process over and over again. So we can run it maybe 20 times and allow it to give us an average of all of that to give us a really accurate result. We can also put in numbers as just hard numbers. So in this case, I'm putting in 45 seconds to represent the washer, and we'll go ahead and put that in there as well. So now that we have that, we're ready to go ahead and run our simulation. So we'll go ahead and just simply tell it to play here. So just going back to the ProModel ribbon, we select simulate, and we can now see our simulation run. So this gives us a graphical representation of how the product is going to flow through our line. It's nice because it starts showing us early on where we're going to see problems. So obviously there's no conveyors or anything that's in here yet. So we're not really seeing anything as it is yet. But what we can do is get a pretty good idea of how many parts can go through this in a 10-hour shift. So we've got all of our parts as they are. So now what we'll do is start making some changes to our layout. We're going to utilize the factory design utilities from Autodesk to give us accurate representations of the machines and equipment, so we can get good space claim on the floor. That way we can avoid the chance of having to have change orders later on. So we have the 2 Chirons that were there in the standard library, which has over 2,500 standard components available to users, and allows you also to be able to add any kind of asset or block that you would need that can customize it to your needs. We can take the ones that are there and change them, or we can add our own from literally almost any CAD system. You'll notice too, if I move this product, so if I take this machine and move it, that the flows automatically update with it. So what that's doing is it's giving us real-time distance. It's accurate distance to scale, so we can look at the part distance that's traveled here. And also we can look at things like the distance traveled by the workers that are doing all of the operations at that time. So let's go into the browser here, and we're going to use from the factory design utilities, from the standard components that they have there. I'm going to grab a conveyor and put it in here because we have this equipment pit in the middle here that won't allow us to put our machines right next to each other. So what we'll do is allow the conveyor to be able to carry the part from station to station for us. So we're going to make a change to our layout as we go here too. Now I'm also going to add in some ball transfer tables at the end, and these will work as kind of like queuing stations on the end, giving our operator a spot to go ahead and pick up the parts. So what we need to do now is tell ProModel that these 3 objects that are right here from the factory design utilities are conveyor objects. And now we can start applying properties of speed and direction for that conveyors. We can also add in these 2 locations here, and we can start adding things like the flows that go into those. So simply right-clicking here, we can add the routing in here. So we're going to route now from that washer to that ball table. We're going to go from that ball transfer table that we've got right there, and we're going to route to our conveyor. So now that we have that, we'll route into the conveyor, and then we'll go ahead and route it again to the other ball transfer table. So again, really easy to make these changes, and it's easy to get a heads up display of what's exactly is going on in our process. So now that we have that, we'll just go ahead and tie in the routing over here as well. So these things are going to affect our output as well, right? Because we've got conveyors, we have speed, things happening like that. And we also start looking at where things are starting to bottleneck. Every process has a bottleneck of one type or another. It's a matter of understanding where that bottleneck is and making sure it doesn't affect us. We also get 3D for free. So this allows us to be able to take that 2D layout that we had by using the factory design utilities. We can now generate a 3D model from that. So again, just one click, everything opens and it works. And for us to be able to animate this, again, is a one-click workflow. We simply click and tell it to show us that simulation running inside of an environment provided by Autodesk called Forge. And it allows us to be able to view this as we go. We can also rotate around in here. We can zoom and be able to better understand how things are going to work. So again, this is a nice tool to be able to show to management how things will be. We also get these really nice dashboards in our output viewer. This is completely customizable. You can make it look any way you want to by simply dragging and dropping the templates that you wish to have. So in this case, maybe we want to add costs to here and start looking at that. Maybe we want to add a table that has the costs in it instead of just a graph. So it's going to tell us how much is spent in that cell during the amount of time that the simulation is run. So that very quickly gets us through the basics of how we would do this. So now what we're going to do is we'll take it a bit further. We're looking to get 300 or more parts a shift out of this line. So again, we're going to run it. And you'll notice now that we have the part that we're machining actually represented in the layout. So we can see that coming through, and we can see how things are bunching up on the conveyor. We can see the people moving around too. These are what are called resources. So resources could be robots or AGVs or people as we go. And we can see as we run it here, it looks pretty good. We've got 300 of them. We're getting 322 out, and our guys aren't overworked. So as I had said before, the only constant inside of manufacturing environment is change. So in this case, the industrial engineer has told us that he wants to make a change to the process. He's seen, by using lean methodologies before, that they were having problems with the quality of parts. So what they want to do is add an inspection station down at the end here. So using the factory design utilities in 3D or 2D, we can place our objects. Very easy to put that in. And we can see now that we can reposition this inspection station on top here, and we can resize that table underneath there because all of the objects that are in the factory design utilities are parametric. So we can get the size there and make sure that everything fits accordingly. We'll go ahead and drag that in and make it look good. And the next thing we need to do is add a couple of containers. So in this case, this will be for our good parts, and the other one will be for our reject parts. So we've just added that in 3D. So the nice thing is, again, you can use whatever environment is comfortable to you to do your layout work. So once we open it again in AutoCAD, we're going to see that the layout is going to update for us. And this will allow us the opportunity to add the flow characteristics into our layout. So where it exited the system before, we're simply going to add route. We're going to say that we're going to this new inspection station, and also that our parts are going to have to go to these bins. Now, rather than being first available, we want to have a percentage of parts go to each bin. We're saying that 90% of our parts are good and 10% of our parts are reject. And again, this can be studied as well too, and variability can also be applied to this. We want to assign that guy that's right there, man one, to also do this. So this, in his other task before, where he's doing machining and washing, he's also doing inspection. So we've added that to the process. So it seems like it'd be a pretty easy thing to do, but as we start seeing things go here, we're noticing that this guy's running all over the place now. And we can see that things are starting to bunch up on the conveyor because he's not able to keep up. In fact, we can look here now and see that we can only get 229 parts out of our system now, the way that it is. And our guy who's working on that line is utilized 96% of the time. That's pretty high. We never usually want to be higher than 85%. So we're going to use the scenario manager to make a very simple study here. All we're going to do is say that we want to add another operator to that other station. But we could add all kinds of things in here. We could play around with the machine speeds, conveyor speeds, anything we like, and we can run all of those scenarios back to back and let the software help us select the best situation for us. And you can see up in the right-hand corner, we're actually seeing the hours as it runs based on the simulation. So we're running at 7 minutes and 56 seconds as we go here. We can take that and run that all the way out through the 40 hours, and we can see the simulation now. So this is as it was as a baseline. Here's what it is in the new version. So we're over our 300 parts, which is good. And we can see also that the operator now is utilized a lot less. So again, we'll take a look at this in our animation environment in 3D. And we can see now that these parts are running down the line, and that you'll notice now, instead of one operator, there's two. So it automatically put the other operator in place and allows us to better understand. And we can see too that one operator is really kind of grounded right at that inspection station. So we can see that as well. We can also study in here what the cost effects would be by adding that. So again, it allows us to make better decisions faster as we go here. And if we look at the outcomes on this, the results here, we can see that we are getting the number of parts that we need versus what we couldn't get done with that station in there. We're also able to see that our guys are utilized, or a person is utilized 65% of the time versus 96% of the time before. So again, much more efficient and works a lot better. And you can reuse this simulation over and over again. You can also use save copy as to make new simulations from that. So it makes it very easy to test over and over again. So let's look at something that's a little bit more complicated. This is an engine assembly line for a 4-cylinder engine. So what we're going to do here is take a look at how the parts are going to flow through this process. So in this case, it's a U-shaped line where we're going to be putting installing the crank, the pistons, the heads, and all of the other parts as well. And we can see that we've got all of the times put into place here. So let's go ahead and simulate this one, and we'll get a look at how this is going to work. So again, it's just doing the quick compile of all of this information, and you'll now start seeing this model run. So here we go. We can now see the engines going through here. We can see the AGV coming and dropping off the parts on the line. And also we could have an AGV that's picking them up on the other line. Now I haven't worked that into the process yet, but it's easy to add. But we can see here too, as things are going through here, as the engine is changing or we're adding more parts to it, we're seeing that graphically represented as we go. And we can see where the person is moving back and forth in the line here. The larger patches that you see there are the representations of the parts. Now I could have those also as blocks too, but we did just for simplicity's sake. So again, what we're going to do is run a simulation here, or we're going to run a scenario, excuse me, where we're looking at some different things. We'd like to get more engines out of the line than we're getting currently. So we're going to play around a little bit with the conveyor speed. We're also going to look at automation. So the automation we're providing is going to cost about $100,000 in nut runners is what we're going to need. So by running these different scenarios, we can see now, just by making those changes, we've made things faster, and we're able to get out 2 more engines per day without really affecting our cost heavily. Okay, so we can go ahead and make those changes very quickly and be able to see that. And again, we can also see this running in a 3D environment. So again, we'll simply open this in Inventor, 1 button click. And now that it's open, we can see our layout. And you'll notice too that we also have the other lines that are here for machining for the heads and for the block itself. And those are simply put in there as a substitute. So we can pull that information up, and we can be granular in this case where we're running the simulation on this smaller area with a lot of detail, or we could run it at a higher level where we're looking at how will everything come together at the end. So we can do that. So again, let's go ahead and animate this, and we'll see this also in 3D running for us. So it allows us to be able to see and understand a little bit better where the problems are going to arise. And also, especially for customers that are selling maybe a turnkey system to another customer, this allows them to be able to show something to their customer probably that their competitors are not showing them. So we have confidence to make sure that things are going to work the way that we would hope. We also have the ability for those that are writing the check for our process to have them better understand what our design intent is. So again, it makes it easier for people to understand and be able to communicate our design intent better. So we can see here too, I can rotate around in here as I wish. I can zoom in closer as this runs, and we can start seeing everything as it performs. So in this case, we'll come down to the end of the line here. The guy down on the right end there is going to be putting on the, he puts on the valve cover and also puts the oil pan on. And down on the end here, this guy is responsible for putting on the manifolds and the electronics. So we can see how it's going to look like as a finished product as it goes out of there. So again, we can see the work that's getting done and it gets shifted down the line for us. So in a matter of a few minutes, we were able to better understand our line layout and better understand what our outcomes are going to be. We can see also that we have our different states based on our scenarios. And we can also see all of the costs and the overall performance of the line. And again, in a completely customizable workspace. So the outcome of this, in its simplest sense, is that our capital expenditure for automation, which is what we're looking at, is it worth making this change? So what we said is about $100,000 to buy the equipment. It allows us to be able to now get out 2 more engines per shift, which means that we're going to gain another $6,000 per shift on those engines. So that you can figure about $3,000 an engine. So if we look at it that way, our investment payback on this very simple example here is about 8 working days. So this is definitely worth doing. We can make the changes very quickly and we can feel confident about it, right? So that's what it does for us, is we have our critical questions answered. 1, will everything fit without colliding, which would cause us problems and cost us money in things like change orders. But we can also see that it's going to perform, and we have the data to prove it and back it up. So this allows us to have design confidence, and we're certain, or a lot more certain. Of course, there is no certainty in anything 100%, but we definitely got a better bead on what it is that we're trying to do here. And it allows us to have a lot more design confidence as we do it. So the technology platforms that we use today, we were using the factory design utilities from Autodesk, which includes Inventor, AutoCAD, Navisworks, to do the layout tasks. But we weren't utilizing ProModel Optimization Suite. That is the underlying engine that's actually under ProModel AutoCAD Edition. It does provide some other capabilities that the ProModel AutoCAD Edition does not, such as the ability to do things like statistical curve fitting and analysis. So everything that runs out of the AutoCAD Edition, however, opens right up in ProModel to add that. I would say that the AutoCAD Edition does about 95% of what the optimization suite does. So it allows us to be able to work in both environments and be able to work that back and forth. So the next steps, what should we do next? Well, if this is something that's interesting to you, and I would hope it would be, as you know, the way that the world is now, change is happening faster than it ever has before. And the ability to make our changes and be able to make sure that things are going to be right the first time is now paramount and critical. So even more so than it was in the past. So the ability to be agile is very important, and that's what these tools help provide. So if this is interesting to you, we'd like you to reach out to your NextGen sales rep, and we can go for a deep dive into your process. And from that, we can do things such as a very simple proof of concept based on your process. So that way we can get a feeling of confidence for that as well. So that was everything that I was planning on showing today. And this worked out actually pretty well because it's going to leave us about 15 minutes for questions and answers. So from there, I'm going to hand this back over to Joy and we can start answering questions.
All right. Well, thanks, Mike. So you all can drop your questions in the Q&A if you would rather ask your question verbally, just use the raise hand button at the bottom of your screen controls, and I will unmute you.
Oh, stunned silence. I either did a really good job or I scared everybody to death.
It was a lot to absorb. They got to think it through, maybe.
Yeah. Yeah, and I apologize for the rate of speed on that, but as Joyce said, there's a lot of things to show, and there's a lot of power here that allows us to be able to make better decisions. So any questions that you'd have, feel free to reach out in here, or you can reach out through NextGen, and I'd be more than happy to answer any questions that you have.
All right. Well, I think that looks like the end here, that nothing's coming through. So we will give you the rest of your time back. Thank you again for joining us. We have recorded this, so if you want to go back and listen, check our YouTube channel. We will also be emailing this out as well. Most likely probably by the end of the day tomorrow. So again, thank you and have a great rest of your day.